How to manage Cisco iOS images and upgrade your router to the latest iOS image. In this video, we're going to establish a connection to a Cisco 1941 router. I have a PC that I'm working from, and I've got a console connection to the router, and I also have an Ethernet cable connected to the router's gigabit 0/0 interface. In this tutorial, what we're going to do is first set up the IP addressing on both the PC and the router so that they can communicate with each other over Ethernet. Then we'll need to make sure that we have a TFTP server running on the PC and the iOS image that we wish to upgrade to. Next, we'll upload the new iOS image to the router using our TFTP server, and then use boot system commands to boot the router to the new iOS image. Let's start by configuring the IP address on the router, and then we'll move to the PC. I have my console connection to the router using TerraTerm. I'll press Enter on the keyboard, go to Privileged User Mode, and then to Global Config Mode. I'll specify interface gigabit 0/0, enter in the IP address 192.168.1.1, the subnet mask, and then use the no shutdown command to enable the interface. And you can see that the interface changed state to down and then to up. Now let's look at the network interface for our PC. I'll open the local area connection property window, highlight Internet Protocol version 4 TCP/IP version 4, open properties, and you can see that I have already set the IP address for my PC to 192.168.1.3, and I've set the gateway to 192.168.1.1, the address of the router interface. So we should have a connection to the router now. From the router, I'll type exit and exit again, and then I'll try to ping the PC. You can see that I'm receiving an echo reply from the PC at 192.168.1.3. Now that the router and the PC are able to communicate with each other, let's go ahead and launch our TFTP server. There are a number of freeware TFTP servers available that can be downloaded from the internet. I'm using tftpd32.exe. I'll launch the server, and let's make note of a few settings that are of importance. First of all, right here under Current Directory, this is our TFTP folder where we'll be uploading and downloading files to and from the TFTP server. It's currently set to the C drive in a directory called TFTP-folder, which I created. If you need to set your TFTP folder, just click the Browse button and create a folder to be the TFTP root folder. Next, the server interface. You can see that the TFTP server has correctly identified the IP address of the server as 192.168.1.3. Let's look into our TFTP folder. You can see that I've already placed an iOS image for the 1941 router inside of it. iOS images can be downloaded from the Cisco.com website with proper credentials. This is the iOS bin file or iOS image that we're going to want to upload to our router. I'll open TerraTerm once again, and before we do anything, let's do a show flash and look in the flash memory to identify the current iOS image. You can see here, this is the flash memory. Item number 1 in the directory shows C1900-Universal K9, and you can see it says 152-4. This is iOS version 15.2 revision 4. You can see it's a bin file. We're going to upgrade this router to the latest version of the iOS 15.3 version 2. To do this, I'll use the copy TFTP flash command, and this will copy from the TFTP server to the router's flash memory. I'll press Enter, and it asks for the IP address of the remote host or TFTP server. I'll put in the PC IP address and press Enter. The source file name is the file name of the iOS image that we wish to upload. I'll go back to the folder where the iOS image is located, highlight the name, do a Control-C on my keyboard, and then paste it into TerraTerm. You can see there's the full name of the new image. I'll press Enter and accept that this is indeed the destination file name. You can see it here in between the brackets. And you can see the file transfer has started. The TFTPD32 TFTP server should let you know right away that a transfer is taking place. And you should be able to follow the progress in the TFTP server window. You can see here the exclamation points indicating successful transfer of data. At the end, it verifies the bytes that have been copied. Let's issue a show flash command, and you can see that item 8 in the directory of the flash memory is our C1900 Universal K9. You can see 153-2. So we now have iOS version 15.3 uploaded into flash memory. Modern Cisco routers have plenty of flash memory to accommodate storing multiple iOS image files. However, if you have an older router with barely enough flash memory for one iOS image file, then you will have to back up the current iOS image to a TFTP server and delete the current image file before uploading the new iOS image file. This process is not covered in this video. To make the router boot to the new iOS image, we'll need to go to Global Config mode, type no boot system, and then use boot system flash : and then we'll want to put in the name of the new iOS image file. I'll highlight the name, do an edit, copy, and then right-click to paste it, and press Enter. If necessary, I can change the boot system command to boot back to the previous iOS image version. And we've now told the system that when it boots, to boot from flash memory using the C1900 version 15.3 as opposed to the previous version 15.2. I'll exit out of Global Config, save my configuration, and reload the router to see if the new iOS image loads. Proceed with reload. I'll press Enter to confirm, and the router should reload and boot to the new iOS image. You can see right here as the router boots up that the new iOS has been recognized. We can identify it right here, version 15.3, version 2, which is the iOS that we intended to upgrade to. The router has rebooted. I'll type EN to get to privileged user mode and issue a show version command. And you can see that the new iOS image, system image file, is flash C1900 Universal K9, and you can see right here 153-2, iOS 15.3 version 2. We have successfully upgraded to the new updated iOS. Working with iOS 15 image licenses on an Integrated Services Generation 2 router or ISR G2 device. By default, Cisco routers have the IP base license installed. This gives the routers the capability to use EIGRP, OSPF, RIP, NAT, DHCP, access lists, PPP, and more. Additional licensing can be purchased, which will unlock added features for the routers. There are 3 packages or 3 additional licenses that you can install: the security license, the Unified Communications or UC license, and the data license. The security license will unlock features like VPN technologies, IPsec, and intrusion prevention system or IPS technology. The Unified Communications technology package will unlock voice over IP and voice IP capabilities. And the data package will unlock enterprise-level functionality like multi-protocol label switching or MPLS, and more. Not all routers support all licensing options. For example, the 1941 Integrated Services Router does not support the UC license. There are 2 main types of licensing with the Cisco IOS: permanent licensing and evaluation right-to-use licensing. To install or add an additional permanent license to the Cisco router, you'll need the product ID number and serial number, also known as the Unique Device Identifier or UDI. You'll need to purchase a package or feature, also known as a product activation key, and then using the Cisco License Manager, CLM, or the Cisco License Portal, you can obtain a license file with your unique device identifier and your product activation key. Once you have your license file in hand, you can upload it to the router using a TFTP server and then install the license file. Evaluation right-to-use licensing enables you to install any of the additional licensed features supported by your router and use them for up to 60 days. All you have to do is accept the end-user license agreement, put in the license boot module command to activate an additional technology package, save your configuration, and then reload the router. Cisco academies that have signed up for NetAcad maintenance are able to use the RTU license beyond the 60-day evaluation period with the security and UC technology packages. Let's see if we can add the security technology package to our Cisco router. I have a console connection to a Cisco 1941 router using TerraTerm. I'll type enable to get to privileged user mode, and let's put in a show version command. At the bottom of the show version command, you can see the license info. The license unique device identifier. This is the product ID, Cisco 1941/K9, and then the serial number. You can see the technology package license information below. IP base, security, and data. The Unified Communications package is not listed, as the 1941 Integrated Services Router does not support it. From this output here, we can tell that this router currently has the IP base K9 current package. It's a permanent license, and on the next reboot, it's also going to be at the IP base K9. Security package, none. Data package, none. So we'll try to unlock the security technology package and add an evaluation right-to-use license to this router. I'll type in a show license all command and press enter. And you can see in the output, feature IP base K9 permanent license active, feature security K9 license type evaluation right to use. Right now this license is not in use and the end user license agreement has not been accepted, so we'll need to accept that. Let's enter the show license UDI command. In the output from this command, you can see the unique device identifier, the product ID, serial number, and that the unique device identifier is the product ID followed by the serial number. To activate the security technology package, first I'll need to go to global config mode, and once in global config mode, I'll need to accept the end user license agreement. License accept end user agreement, and press enter. Accept, yes or no. I'll enter Y, and you can see here the response. License 6, end user license agreement, accept all. The end user license agreement is accepted. Now, to activate the security package, I'll type in license boot module, and then I'll put in a space and a question mark. You can see that the module name for this model router is C1900, and it tells me that right there. So I'll enter C1900 space technology dash package, and then a space and a question mark, and you can see that I have a choice between the data K9 technology package or the security K9 technology package. So I'll put in security K9 and press enter. You can see I'm given a message. Use the right command to make the license boot config take effect on next boot. So for this to work, we need to now save the configuration. I'll type end and then copy run start to save the configuration file. I'll press enter to accept. Let's do a show version command before we reload the router. You can see here at the bottom, security, the current technology package says none, but for next reboot, the technology package security K9 will be activated. So I'll type reload and press enter to confirm. The router has reloaded. I'll type enable, and let's issue the show version command again. And you can see that the security package is now currently activated. Notice under type, eval right to use. There is the evaluation right to use license. I'll type in a show license all, and we can also see that the eval right to use license for the feature security K9 is active and in use. If I want to save my license, I can type license save flash : and then I'll type router underscore license underscore files. And let's see if we can save our license to flash memory. I'll hit enter, and you can see the license lines saved, and I'll do a show flash command. And at the bottom, under line 10, is the saved router license files.